So now we can see the second method. See now, when they give you a 3 cross 3 matrix, we need to find the determinant of A. Determinant of A is equal to, we put the determinant symbol A, B, C, D, E, F, G, H, I. That is equal to, now what you do, we take the first element A, first row, first column. Forget the first row and forget the first column. That is A. Now this, we have to see what is remaining. E, F, H, I, that is remaining. So that we put it as a determinant, small determinant. It is a 2 cross 2 determinant. Minus, this minus is a formula. So now what we have to do, we take the second element in the first row, that is B. Now we have to forget the first row and the second column. So now we take what is remaining. So that is D, F, G, I. So we have D, F, G, I within the determinant. It is a 2 cross 2 determinant. Plus the last number in the first row, that is C, and we put a determinant symbol, that is D, E, G, H. D, E, G, H inside the determinant, 2 cross 2 determinant. So now this 3 cross 3 determinant becomes a 2 cross 2 determinant. Now we have to find the value of this 2 cross 2 determinant, and we have to multiply with the A, and we have to multiply with B, we have to multiply with C, we have to add and subtract, we get the answer. So this is the one of the easiest way to find the determinant. Now let us find the determinant value by using the second method. So determinants of 3 cross 3. Okay. So now the first example, find the determinant of 1, 0, 1, 3, 2, 2, 4, 5, 1 within the matrix. So that is equal to, so now let us take the first row. The first element is 1. So we write 1. So now we have to forget the first row and the first column. So what is remaining is 2, 2, 5, 1. So we have to write it as a 2 cross 2 determinant. 2, 2, 5, 1. So next one is minus. The second one should be always minus. This is a rule. Next one, the second element in the first row is 0. So put 0, and now we have to forget the first row and the second column. So what is remaining is 3, 2, 4, 1. So we write as a 2 cross 2 determinant. Plus, this plus is a rule. So we have to go for the third element in the first row. So that means we have to forget the first row and the third column. So what is remaining is 3, 2, 4, 5. So 3, 2, 4, 5. It is a 2 cross 2 determinant. Now what we have to do? We have to find the value of this determinant. 1 into we have to multiply. We know how to find the determinant of a 2 cross 2 matrix. So that is 2 into 1, 2, minus 5 into 2, 8. So it will become 1 into minus 6. So it will become 2 into 1 minus 5 into 2 is 10. So 2 minus 10 is 8. So it is minus 8. So you get minus 8 for the first one. The second one, since we are having 0 before the determinant, the value will be always 0. Plus 1 into, we have 3 into 5, 15, minus 4 into 2, 8. That is 1 into 7, that is 7. So we get 7 as the value of the third determinant. So plus 7. So now minus 8 minus 0 plus 7, that is equal to minus 1. So now this minus 1 is the value of the 3 cross 3 determinant. Now let us go for the second example. Find the value of a DET. DET means determinant of 1, 0, minus 1, 2 0 minus 2, 3 minus 4 1. So now the first step is we have to take the first row, first column, and we have the number 1. The first number is 1, and we have to take what is remaining. That is, forget the first row and first column. We have 0, minus 2, minus 4, and 1. Now we put minus. This minus is because of the rule. Now we have to take the second number in the first row. Second number in the first row is 0. 0, and we make a determinant. Forget the first row and forget the second column. So we have 2, minus 2, 3, 1. Then plus we take the third number in the first row, that is minus 1, and now we have to forget the first row and third column. It will be 2 0 3 minus 4. So it will be, now we have to simplify this 2 cross 2 determinants. So when we multiply, we get 0 minus 8 minus the second one will be 0 because of the 0 is before the determinant, so any value will be 0. So minus 1 into 2 into minus 4 minus 8 minus 0. So 1 into minus 8 minus 0 plus 8. So now we are having minus 8 minus 0 plus 8. So plus 8 minus 8 cancel. The answer is 0. So 0 is the value of the given determinant. Next, we are going to find the inverse of a 2 cross 2 matrix. Number 1, the inverse of a square matrix A is the matrix denoted by A power minus 1. A power minus 1 is the inverse of A, which satisfies A into A inverse. A multiply A inverse is equal to I. A inverse into A is also I, where I is the identity matrix. Identity matrix means the diagonal elements will be 1, all elements, other elements will be 0. So when you multiply A and A inverse or A inverse and A, we get the identity matrix. Next, the second one, a square matrix A which has no inverse is called a singular matrix. So a square matrix will have no inverse when we find the determinant value of that matrix is 0. If the determinant of that matrix is 0, then there will be no inverse. The inverse does not exist. So such type of matrix are called singular matrix. So now finding A inverse for a 2 cross 2 matrix A. So we are going to have a rule. We are going to make a rule. We have to understand this rule to find the inverse. If A is equal to A, B, C, D is a given 2 cross 2 matrix and the determinant DETA is not equal to 0. Determinant of A is not equal to 0. Then A inverse is equal to 1 by determinant of A, and we have to write the formula for A inverse is 1 by determinant of A, and the matrix, inside the matrix you see we have to interchange A and D from A. See the D in the place of A and A in the place of D, and also we have to change the sign of the other diagonal BC we have to change the sign. Plus means minus, minus means plus. Here both of them plus, so I change both of them minus. So we know that the determinant of A is nothing but AD minus BC for a 2 cross 2 matrix, and inside the matrix we have this small change. So we, for downward arrow we change the numbers, For the backward arrow, we change the sign. So this is the rule to find the inverse of a given matrix. So if you want to find the inverse, first you have to find the determinant of that matrix. Then we have to change the diagonal elements, forward diagonal elements, and we have to change the sign of the backward diagonal element. So this is the rule that we have to save in our mind. So now we are going to see an example for finding the inverse of a 2 cross 2 matrix. If A is equal to 2, 6, 1, 5, then determinant of A is equal to 2, 6, 1, 5. The first step for finding the inverse is we have to find the determinant. So I make a determinant 2, 6, 1, 5. So now we have to multiply the forward diagonal elements, that is 2 multiply 5 minus 1 multiply 6. So it is 10 minus 6, that is equal to 4. So 4 is the value of the determinant, which is not equal to 0. So therefore this matrix is not a singular matrix. So it's not equal to 0 means the inverse exists. Now let us find the inverse. A inverse is equal to 1 divided by the determinant value. The determinant value is 4, and we open a matrix bracket, and now we check with the matrix A. We change the place of the forward diagonal, that is 5, 2, 5 becomes 5, 2. On the backward diagonal, we have positive 6 and positive 1. We changed as negative 1 and negative 6. So now what we can do is we got the matrix A inverse, but 1 by 4 is outside. If you want, we can multiply this 1 by 4 inside every number. So it will become 5 by 4. So when you multiply 1 by 4 with minus 6, it is minus 6 by 4. 1 by 4 into minus 1 is minus 1 by 4. 1 by 4 into 2 is 2 by 4. So now the answer is 5 by 4 minus 6 by 4. If you want to simplify, you can simplify. It will be minus 3 by 2 and minus 1 by 4, and over 2 by 4 it is 1 by 2. So this is the inverse of the given 2 cross 2 matrix. Now if you want to check whether your answer is correct or not, so what we can do is we can multiply A with the A inverse. If we multiply A with the A inverse, A multiply A inverse should be a identity matrix. So if you get the identity matrix, then your answer is 100% correct. So we know A. We know A is the given matrix 2, 6, 1, 5. Multiply with A inverse. A inverse is 5 by 4 minus 6 by 4 minus 1 by 4, 2 by 4. So now what I am going to do, I am going to multiply this 2 cross 2 matrix, and I will get a 2 cross 2 answer matrix. So when you do by using the matrix multiplication, first row first column, first row second column, second row first column, second row second column. So and if you simplify, you are getting 1 0 0 1. This is a diagonal matrix, and it is a 1 1 means it is a identity matrix. So it is nothing but I. So our answer A inverse is a correct one. So the next example is finding the inverse again. So now if B is equal to 2814, then determinant of B, we have to find the determinant first. It will be 2814 within the two lines. The two lines means it is determinant. So now we have to multiply the forward diagonal elements. 2 multiply 4 minus 1 multiply 8. That is equal to 8 minus 8, that is equal to 0. So the determinant of the matrix B is equal to 0. If the determinant is value is 0, then inverse does not exist. Because the reason is since it is determinant is 0, the inverse does not exist. And we can also say that B is a singular matrix. Singular matrix because determinant value of B is 0. So for this problem, the inverse does not exist.